All right, we are continuing solving equations by elimination. If you missed the first video, please go back and watch the examples from the first video. Right now, I want you to take a moment and see if you can answer this question on your own. In the system below, for what value of A can you eliminate a variable by adding the equations? Okay? For what value of A? So A is right here. If I add these two equations together, what would make that variable eliminate? All right, for what value of B can you eliminate a variable by subtracting the equations? All right, here is B. If I want to eliminate this variable by subtracting, what would B have to be? All right, hopefully you've had time to think about that and write down your answer. All right, if you want to add the first two, if you want to add the equations together and you want A to eliminate, that means they have to be the same number but different signs. Since this is negative 7/5, A would have to be positive 7/5. A positive 7/5 Y minus 7/5 Y would cancel or eliminate, okay? All right, for what value of B can you eliminate a variable by subtracting the equations? All right, so I have 1/2 x. If I want to subtract a number x, what would that number have to be for that to disappear or eliminate? 1/2 x minus 1/2 x would make that eliminate. So B would have to be negative, or sorry, B would have to be 1/2 x, but then you would subtract it. So B would be 1/2, then you would subtract the equation to make x eliminate. All right, hopefully you got those on your own, and that should help you understand the process of elimination and why you do it and why it works. All right, example 3. A business with 2 locations buys 7 large delivery vans and 5 small delivery vans. Location A receives 5 large vans and 2 small vans for a total cost of $235,000. Location B receives 2 large vans and 3 small vans for a total cost of $160,000. What is the cost of each type of van? Okay, so like in our other systems of equations, we need to define 2 variables, our x and y. So we can say, let x equal the cost of, here we're going to have large vans and small vans. So x is going to be the cost of, let's say, a large van. And so y could be the cost of a small van. All right, now we can look at what we have. So they have 7 large and 5 small total for delivery vans. Location A receives 5 large and 2 small for a total cost of $235,000. So we can do the number of large vans times the cost of a large van plus the number of small vans times the cost of a small van equals the total cost of vans. So let's write an equation for location A. So 5 large times x, which is the cost of a large van, plus 2 small times y, which is the cost of a small van, and that's going to be a total of $235,000. And then location B receives 2 large vans, 2 times x, and 3 small, 3y, and that's going to equal $160,000. All right, now you can see that if we add these, nothing eliminates. If we subtract these, nothing eliminates. And we can't just multiply one equation because we're still not going to get rid of just one variable by eliminating or multiplying by one equation. So we're going to have to multiply both equations by something. So 5 and 2 are both multiples of 10. 2 and 3 are both multiples of 6. So you can decide which variable you want to eliminate first. It doesn't matter. You should get the same answer if you do it correctly. All right, so since the numbers are a little bit, well, it doesn't matter. Let's multiply the top by 2 and the bottom by -5. All right, so 2 times 5x is 10x. 2 times 2 is 4y. And 235,000 times 2 is going to be 470,000. Remember, when you multiply the whole entire equation. So -5 times 2 is -10x. -5 times 3 is -15y. And 160 times -5 is -800,000. So -800,000. All right, so we can see that our 10x minus 10x is now going to cancel if we add these two equations together. 4y minus 15y is going to be -11y. And then I've got we got 470,000 plus a -800,000. So that's going to give us -330,000. All right, so we're going to divide both sides by -11 because we're trying to solve for y. And that gives us y equals $30,000. All right, so we solved for y first, the cost of a small van. So the cost of a small van we know is $30,000. All right. Now we got to find the cost of a large van. So the cost of a large van, we need to take our 30,000, our y value, and plug it back into one of these two equations. It doesn't matter which one. So just choose one. So let's say 5 times x plus 2 times y. Y is now 30,000. We've already solved for it. And that's going to equal $235,000. All right, so 5x will come down. 2 times 30,000 is $60,000. And that equals 235. Subtract 60,000 from both sides. So 5x equals 235 minus 60 is 175. And we're going to divide both of those by 5. And if we do that, we get x is $35,000. So a large van is $35,000 and a small van is $30,000. So what do you need to do? As always, you need to plug these in and check it. All right, so I would just take my calculator and plug those in very quickly. Let's see if we can plug this in. All right, so we have 5 times x, which is $35,000, plus 2 times $30,000, and if this is right, this should be 235,000. That's what we get. So now we're going to do our second one, which is 2 times x, 2 times the cost of a large van, so 2 times $35,000, plus 3 times y. That's the cost of a small van, which is $30,000. and that should be 160,000. And it is. So we can see that both of these are correct. So this is the solution to our system. So a business with 2 locations buys 7 large vans. 5 plus 2 is your 7 large vans. 5 small vans. 2 plus 3 is your 5 small vans. And each large van costs $35,000 and each small van costs $30,000. All right, study tip in example 3, both equations are multiplied by a constant, so that constant of the y term are the same. All right, so I actually multiplied to make the x term the same instead of the y term. So you can see that kind of works for either one of those. All right, that's all for example 3. If you have any questions, please let me know.